think it's what we had before.
But
I think it's one we chose first time.
right.
Before
But
s-
what's the
Can't be.
fillet? Is it? Did you manage to find that finally?
if we go to it, it should tell us.
Drawing. Yeah.
No, it doesn't tell us on this drawing, I'm afraid.
It's not RE anymore.
No. Now, if we could go and try and find this bearing, YEL 210 2F, okay.
Where did we get the RE previously? Do you know that?
It was on a certain bearing. This is a unit. Then we can choose. If we look at the bearing, YEL 210 2F. Okay.
210 2F.
What means roller bearing in a deep groove single row. No,
210 2F.
I just don't understand it. The designation seems miles up. Search. What do we say it was?
210 2F.
I just put last time. We couldn't find what we were after. Which is absolutely. Sorry, can you get product?
It's Y bearing.
Okay, so what I mean is Y bearing is an adapter sleeve, I think we want to say. That's bearing, so what is 210?
210 2F. Oh, there's a K now.
We didn't want one on an adapter, sorry, we didn't have an adapter. Y bearing with
Eccentric.
locking collar, sorry, that's when.
Yes. Back to the second page.
YEL, just, yes, so it's going to be a few pages long because they're quite large bearings. Next page on.
Last page. Yeah, okay.
YEL, so it's 210.
2F. Yes.
Okay. The diagram, radius 1.2. Okay. So the designation of that bearing is YEL 210 2F. We're just about to run out of tape, I think.
Pi not 2 4. Okay, not pi not 2 4. And 1.4. I think it was somewhere.
Up there.
2.3.
2.3, okay. Let me just drop 2.3 as key in here. And what we find is, at that bearing, which is at node 2, we're allowed 7.9 and we have 36, so we're comfortably inside it. 79 point times 76, we have 36 times 76, so we're comfortably inside it, okay?
Good. This
Now-
is bearing A.
Okay, so we're fine for stresses, for bending stresses, in terms of the bending and torsional stresses. Now what we need to do is find out we use some keyways on these pulleys.
Right.
Keyways are also not stress raisers.
So we need to make sure that the keyways is in fair angle
This
the
stress.
torsional.
Yeah, I think we're actually fine for stress at that end. We're absolutely fine for it.
There's any torsional stress on the motor and the pulley.
Yes, there always need keyways.
Yeah.
So we need to choose those. Now I think the tape is going to run out any second. So what I'll do is just stop this and we'll start the new activity afterwards on the new tape. Now we've just left the task of designing the keyway. Now we have a catalogue that says what keyway dimensions we should choose, essentially based upon the diameter of the shaft. Let's choose the keyway for the first. Basically what's left to choose is the length of the keyway. Now,
yeah,
or the minimum length, because
minimum
see
length, and then
that
we can
compares to
decide.
the width of the pulley, or the length of the pulley in that direction.
Okay.
So from the catalogue, we have a shaft that's 60 millimetres
Is
diameter,
our shaft about
and that's for the
for the
pump
pump?
pulley. Okay. Yep. Now, so between what's it?
Between 58 and 65.
so up on between 58 and 65, we're left with the dimensions are 18 by 11.
The
Yeah.
VH, yeah? V times H
Yeah.
is 18, 11, 4
And then the rest is
shaft
yeah.
diameter.
Okay, so we need to work out for the thing fail. The shear force is
Shear force.
Torque is newtons per metre, so you need newtons, so it's torque divided by the radius.
Yeah. Shear force is torque
divided by radius. Now what's the torque?
Torque was
It's like 240 something, but I'm afraid I don't know it off the top of my head. Is it in the paperwork somewhere? So the radius is 30 times 10 to the 3, minus 3 anyway.
But radius is half that shaft diameter, right?
Yeah. Oh Lord, I could be looking at it forever.
Well, we're looking for.
So you just the
It's
torque.
the power over
Yeah.
the rotational speed. Yeah.
Essentially,
Find that.
yeah. So it was 580
Calculation.
originally, but we've got it computed, so that's everything out.
It's the one that has
Is motor
power.
or power?
It's just the
the one in the shaft.
torque of the shaft, yeah.
We can calculate that again, right? Because we know that the rotational speed was 580
580 revolves per minute, yeah, what's that radius?
to pi 160.
This one.
Calculator should have 15,000 divided by 247.
6, that rings a bell. Yeah,
Yeah,
240.
that's the one. Yeah, exactly.
Is it?
Yeah.
247.
Is it?
Yeah.
247.1.
47.1 meters. 30. Eight, 2, 3, 6.7 newtons.
Okay. Now, the shear stress is the force over the area.
Yeah, which is 8,236.7 by the area of
The area is the
BC
width,
Yeah, it's B.
which is
which is B is
18 multiplied by 18
Right,
times 10,
yeah.
10 to the minus 3,
Balance.
18 times 10 to the minus 3 times
L.
the length. So the length
L
is
is the one we need to work out.
length is what we want to know. You can't
Yeah.
change anything else.
And the shear,
Okay.
Yes.
So the shear stress we can have is
maximum shear stress.
Minimum.
we have to work out what's the
And
ultimate
failure.
shear stress
Yes,
and
as long
work
as
out the A, B, C, D, and K again.
right. Okay. We need to have the shear strength divided by the safety.
Factor. Yes,
Yes.
exactly that.
Yeah. To
Yes.
give you the maximum.
Yeah.
Okay.
So Tor A, but it's Tor A is Tor allowable. Well, just can you just reconfigure that? Well, it doesn't need to. Just exchange L and Tor basically. Just write. Can you just write the equation in terms of L?
In terms of L. Mhm. Yeah.
You just put Tor A as well.
This is to
A is in Tor allowable. So Tor allowable is equal to ultimate shear stress, USS, or
UTS shear stress
divided by A, B, C, D, K,
and U. Yeah.
NU.
Okay. And this is ultimate shear strength is half.
We take that as a
We can assume. I think
Yeah.
it's
because we have that here. Fortunately, we didn't actually have a values quoted on our material database. So what we have is 9.6 times 10 to the 8 is the ultimate tensile strength.
no. We need the yield strength.
Oh, so you want the
Yeah.
yield.
It's half the yield
The
strength.
elastic limit is 5.85.
5.85
times 10 to the 8, or 5.85.
Okay. Now we need to work out A, B, C, D.
Okay,
Okay.
so A,
Yeah. A.
Go back to that.
Yeah.
Okay. What's A?
the ratio of the ultimate strength of the material to its yield strength. If we just take that, should we take that in as the shear?
That was 1.5 from our material.
1.6.
1.6.
But is it the same in, we're assuming is it the same in
Property.
tension as it is in
Shear.
shear? We're just assuming
I
it's,
think it's this
if we're
one.
wrong, but we'll
Yep.
see. The fatigue factor,
It's 1 because
It's 1
it's
'cause it doesn't
between 0
change.
and maximum.
yeah, it doesn't actually go into
Shock factor
factor.
1.
one. Stress concentration,
Right.
What's that
We
for
have to
kilo?
assume
It's through S and P.
key ways it should be noted which